This takes us to our lesson today, the volume of a cone. You're going to go ahead and put this in your table of contents, and the note sheets that go along with your lesson that you're going to fill out by watching this video lesson are going to get taped on page 77 and 78 when you're finished. The volume demonstration that you just saw explains why our formula that we use for a cylinder, pi r squared h, is divided in 3, because in order to come up with the volume of a cone that has the same radius and the same height as a cylinder, we would have to divide the volume of that cylinder by 3. So that's why your formula is pi r squared h. You're going to divide by 3 to get the volume of a cone when you're working on cones. So for your note sheet, you have a cone with some dimensions listed. Understand that this dimension down here at the bottom, from the center of the circular base over to the outside, is your radius. Your height is going to be perpendicular, in other words, straight up and down from that circular base. So we need to use the 5 for our height. We need to use the 12 for our radius. This dimension over here, this 13, is called the slant height. You will use slant height to find surface area when you get to high school geometry. For this year, we're responsible for knowing how to use the formula for the volume of a cone. Again, we just explained you're going to take the volume of a cylinder, pi r squared h, but you're going to divide it by 3. So just like we calculated for the cylinder, you're going to plug in your radius. In this case, it's 12. Don't forget to square that number and multiply by 5. If you're leaving your answer in terms of pi, remember, do not actually press the pi button on your calculator. You're just going to take 12 squared times 5, hit enter, and then you're going to want to divide by 3. So I did this in 2 steps. You've got your 12 squared. I don't know if you could see this on there. 12 is being squared. You're timesing by 5. Okay, do that in 1 step. And then notice that my answer, actually I think I put in 13 squared, so let's do 12 squared. You're timesing by the height of 5. Okay, that's where I got the 720, and I kept pi in my answer because, again, I didn't type it in on the calculator, but we do have to divide that number by 3. Okay, this is going to simplify your volume answer in what's called, in terms of pi, 240 pi. You do have units that are meters cubed. If you ever do want to multiply the value of your volume and actually get the approximated value, you could do that by just taking what we just had, 240, timesing it by pi, and that's where the 753.9822369 comes from. This answer is not in terms of pi. You can see that it is kind of messy. It's an approximate value because, remember, our calculator can't hold the full power of pi. It just holds an approximate value. So this is pretty close if you have to round your answer off to the nearest cubic meter or nearest tenth of a cubic meter. This is good if you want to leave your answer in terms of pi. So the next question that you have on your note sheet, what they've given you is the diameter of the circular base. So you need to remember that if they gave you the diameter, the radius is only going to be from the center over. So we need to use a radius of 2 centimeters for this question. The height, remember, is the perpendicular from that circular base. So we are given the height of 4. So again, using your cylinder formula, pi r squared h, we're dividing it by 3 because 3 of these cones will fit into a full-size cylinder with that same radius and height. So there's my radius of 2 that was plugged in. We're going to square it. We're going to times by 4. That should give you 16, and now we're going to divide by 3. One of the things that happens frequently is when you're dividing, you're going to get a repeating decimal. So another way I can write this answer is I can say that this is equal to 5.3 repeating pi. I'm still in terms of pi because I have it multiplied by pi, but what I did is I simplified the 16 divided by 3. And this is sometimes easier to use as long as you remember that repeater bar to represent your repeating 3 when you divided your 16 by 3. If you wanted it to be an approximate answer where you actually multiplied your 5.3 repeating times pi, you would get this, 16.75516.082. And again, this is cubic centimeters. You started with centimeters. Its volume, which again is three-dimensional, it holds the space inside, so it's cubic centimeters. Your next example that you're going to tape into your notebook, it gives you a full-size cylinder. So we're going to compare this full-size cylinder with a cone that has the same dimensions, and this will reinforce what you saw in the video. So remember, for a cylinder, you're just doing pi r squared h. The radius is 6. The height is 3. So when you take 6 squared times 3, we're going to leave this in terms of pi. 108 pi is easier to work with than you can see the approximate answer when I did multiply by pi. So keep this number in mind when we do the next part of the question. We're supposed to draw a cone with the same dimensions as the figure above. So we need a radius of 6 and we need a height of 3, but it has to be like a cone. It has to have that point at the top. So when I drew my example, I took my circular base and I put it down here with its radius of 6. I show the height in the center of the cone because your height has to go up to the tippy top point on the cone. So your height is still 3 and your radius is still 6. And then remember, when you find the volume of a cone, we're going to take pi r squared h and divide by 3. So you know what's going to happen when we plug in our radius squared times 3. We're going to get that 108 pi, but we're going to have to divide by 3. So what happens when you take 108 pi and you divide by 3, it's almost as if these 3's cancel in your original formula. But if you were to calculate this, 108 divided by 3 does give you 36. So to answer the question about how your volumes compare, you need to remember it's going to take 3 of these to fill up that cylinder. 36 times 3 is going to give you 108. So we could say the volume of the cone is 1/3 the volume of the cylinder. Example 4 wants you to find out what would have the greater effect on the volume of a cone. Is it going to be that you're doubling the radius or doubling its height? So what we need to do, it says to use the information from question 3b, where we had a height of 3 and a radius of 6. If we were starting with this original shape, we knew that the volume was 36 pi. So what we're doing now is we're actually doubling the radius. So where we had a radius of 6 in question 3b, we're changing it to be 12. So doing the calculation with a radius of 12, you can see that you get a volume of 144 pi. If we were to take the question in, or the shape in question 3b, and we were to keep the radius the same, but double the height, remember the height was 3 inches in the last problem, and now it's going to be doubled, so it's going to be 6 inches. By using the formula with a doubled height, you can see that we've only increased the volume to 72 pi. So, to answer the question, what has a greater effect? It's doubling the radius. Because remember, in your formula, your radius gets squared. Your height is just multiplied against those values. So that's what makes doubling the radius have a greater effect. Now, on the back of your second piece that's going to go into your notebook, we have a couple more challenging problems. And this challenging problem gives us the volume of a cone, 405 pi. We also have the diameter of 18 inches. So right away you know that if we take our diameter and we cut it in half, you're going to have your radius of 9 inches. If we plug in what we know about this question, we have to plug in the fact that we have the volume. So the volume, 405 pi, you can see is substituted here. The formula, pi, stays there. The radius gets plugged in. But notice how they did not give us a value for the height. That's what they want us to find. So your variable, your unknown item, is going to be here. And the rest of the formula, remember, besides pi r squared, is that you're dividing by 3. Well, as you can see from me already working on this problem, I've started to solve for that unknown variable h. H is attached to all this other stuff by either multiplying or by dividing. So one of the ways you know to solve a problem is if you have a divide by 3 that you want to get rid of, you can multiply by 3. So you can see here that I multiply by 3 over 1. If you do that on one side of the equation, you have to do it on the other side. You might also know that I canceled out pi from both sides of the equation. If an equation is balanced and you have the same value multiplied against these numbers and the same value multiplied against these numbers, you can simply divide by pi on both sides. All right, but you notice that I just cancel them off because when you divide, they're going to cancel anyway. So by multiplying by 3, this is how we gain the 1,215. On this side, what I did to get the 81 is I just took my radius of 9 and I squared it, and I left it attached to my height. Remember, that's my variable that I'm solving for. So the only thing left to do is to divide by that 81. When you divide by 81, you're getting a height of 15 inches. And this works out, if you were to go back and check the problem, a height of 15 times the radius squared divided by 3 is going to give you 405 pi. So this just gives you an example of a way that we can use volume formula, but find one of the values over here instead of finding the actual volume like we've been practicing. Your last example is similar to number 5. You want the volume to be about 240 cubic centimeters. You know how tall the cone is this time, but you're looking for the radius. So again, we need to start out with a formula for the volume of a cone, and we need to plug in what we know. We know we want our answer for our volume to be about 240. We know that we have a height that's 14. What we don't know is what this radius is. So this time we're solving for r. R is our unknown variable. So remember what we did earlier to get rid of this big divide sign with a 3. You could do the opposite and multiply by 3 on both sides, so that takes care of that. This time we don't have our answer in terms of pi for volume, so we can't just cancel out pi's like we did before. What we have to do is we have to actually divide by pi, and as you can see in this step, I've divided by pi, but I've also divided by our height of 14. I want to get rid of both of those numbers at the same time, so it's okay to divide by 14 pi. The one thing I will warn you is this. When you use your calculator, you have to be very careful in stating, hey, I want 720 to be divided, and then put this in a group. I want it divided by 14 pi together. I don't want to just divide by 14 and then multiply by pi. I want to divide by both of those items. So that's where you can see I get this decimal answer. And I've approximated it to be about 16. They told us that they want our volume to be about 240 centimeters cubed. So by rounding this off now at about 16, it helps us, because 16 is going to be equal to a radius squared. If you remember how exponents work, we need a number times itself that's approximately 16. Well, that number has to be 4. You remember 4 squared, in other words, 4 times 4 is going to give us 16. So this is how you can find the radius if you're given the volume and the height and you have to use your volume formula to solve for your unknown variable. Now take a minute and make sure that you have your table of contents filled out. Make sure you have your page numbers and your titles and your notes completely taped into your notebook.